What if I told you there's a single number sitting quietly on a routine blood panel that can tell you more about your long-term health risk than almost any other test you could run? Not your cholesterol, not even your fasting blood sugar. I'm talking about vitamin D. And by the end of this video, you're going to understand why calling it just a vitamin might be one of the biggest understatements in modern health. Here's a claim that sounds extreme until you look at the research. Vitamin D deficiency might be the single most widespread nutritional problem on the planet. Some clinicians have started treating it almost like a biomarker of overall resilience, a number that, on its own, gives you a surprisingly accurate snapshot of how well someone's body is functioning as a whole. Today, we're going through the full picture: what vitamin D actually does, why so many people are deficient without knowing it, and the step-by-step chain your body needs to actually use the vitamin D you're taking. Because here's the twist: swallowing a supplement is nowhere near the end of the story. Part 1. What vitamin D actually does. Let's start with the version of vitamin D you probably already know. Back in the 1920s, doctors were puzzled by children developing a bone disease called rickets. Their bones stayed soft and bent under their own body weight because they weren't hardening properly. Researchers eventually traced it back to a lack of vitamin D, which is essential for pulling calcium into bone tissue. Supplement the kids, and the soft bone problem disappeared almost completely. That discovery is why, for most of the last century, vitamin D got filed away in our minds under bone health and nothing else. But that classic bone-building role is genuinely just the tip of the iceberg. Over roughly the last decade, research has exploded around what scientists call vitamin D's non-classical functions. And this is where things get interesting. Vitamin D turns out to be deeply involved in immune function, activating immune cells, regulating how aggressively they respond, and controlling apoptosis, the natural, programmed death of old or damaged cells. When vitamin D is low, inflammation tends to climb because the body loses one of its key regulatory brakes. It also plays a role in neurogenesis, literally the growth of new brain tissue and new neural connections. That matters for recovery after something like a concussion, but it also matters for something as everyday as learning a new skill, since forming new memories requires forming new neural connections. Here's where a bit of controversy comes in. Most of these newer discoveries, immune regulation, brain health, cell behavior, are barely a decade or two old compared to the bone-calcium relationship, which we've understood for nearly 100 years, and some practitioners are still mentally stuck in that older framework. So when someone asks, "Am I getting enough vitamin D?" a lot of clinicians are unconsciously only asking, "Is this enough to build bone?" That might be true, but it completely ignores the dozens of other systems depending on the same nutrient. And there's more beyond immune function and brain health. Vitamin D influences cell proliferation, how cells multiply and mature. It influences cell differentiation, a cell's ability to correctly become a bone cell, a heart cell, a liver cell, or a neuron. And it influences genomic stability, the integrity of your DNA itself. When all three of these processes are working properly, you get healthy, well-functioning tissue. But flip that around and you get a disease defined by exactly the opposite: uncontrolled cell proliferation, poor cell differentiation, and genomic instability. That disease is cancer. And low vitamin D has been consistently associated with more aggressive, less controlled cancer growth. Autoimmune disease is another huge piece of this puzzle, and it's becoming more common every year. The most frequently seen version shows up in thyroid antibody testing. Somewhere around 20 to 30% of people tested show thyroid antibodies. But autoimmunity doesn't stop at the thyroid. Rheumatoid arthritis, lupus, ankylosing spondylitis, psoriasis, and psoriatic arthritis. The list keeps growing, and even type 1 diabetes falls into this autoimmune category, all of them linked, at least in part, to vitamin D status. Then there's the neurological side. Neurodegenerative conditions like Parkinson's disease and Alzheimer's-related dementia show associations with vitamin D. So do neuropsychiatric conditions like schizophrenia and depression. By this point, you can probably see the pattern forming. There is almost no major system in the human body where vitamin D isn't involved in some way. Calling it important is almost comically insufficient. Which brings up a fair question. Is low vitamin D a cause of disease or a result of it? Are people getting sick because they're deficient, or are they deficient because being sick disrupts how their body processes vitamin D in the first place? The honest answer is both. Low vitamin D can trigger or worsen a long list of problems, and being sick often makes it harder for your body to process vitamin D correctly, which creates a self-reinforcing cycle that's hard to break out of without intervention. Part 2. How big is this problem really? Officially, deficient is defined as below 20 nanograms per milliliter on a standard blood test. And using that definition, somewhere between roughly 40% and nearly 100% of the population qualifies as deficient, depending on the country and region studied. In nations with strong food fortification programs, that number might drop closer to 40%, but that still means almost half the population is critically low. In other regions, particularly parts of the Middle East, deficiency rates have been reported as high as 97%. At some point, researchers pushed back and said, essentially, there's no way that many people are actually deficient. The threshold must be too strict. So some guidelines were loosened, pointing out that even at levels as low as 12.5 nanograms, most people's bones still mineralize reasonably well. But notice what's happening there. They're falling right back into that old bone-only mindset. Even 20 nanograms is nowhere near enough once you consider everything else vitamin D is responsible for. There's even a middle category, insufficient rather than fully deficient, which covers anything under 30 nanograms. But again, most of these numbers were built around one narrow question. Can this person still deposit calcium into bone? They were never designed to answer the bigger question. What level do you need for full-body optimal function? Part 3. The hidden chain of steps. Your body needs. This is the part almost nobody talks about. Getting enough vitamin D isn't as simple as taking a pill or getting some sun. There's a whole chain of steps that has to work correctly, and if even one link breaks, everything downstream suffers. Step 1 is production or intake. Classically, you'd get vitamin D by spending time in the sun. UV exposure hits your skin and triggers production. But in the modern world, that pathway is far less reliable than it used to be. Air pollution alone can meaningfully reduce how much vitamin D your skin produces. Most people also wear clothing and spend the bulk of their day indoors, which drastically cuts direct skin exposure. Skin pigmentation matters too. Darker skin naturally blocks more UV radiation, meaning less conversion per minute in the sun. Where you live on the globe matters. The farther you are from the equator, the weaker and less direct the UV exposure, especially outside of midday hours. Age matters. Your skin's ability to convert sunlight into vitamin D declines as you get older. And then there's insulin resistance, which affects a large percentage of the population due to high sugar, high carbohydrate diets, and which also interferes with how efficiently the body handles vitamin D. Given all of that, for most people, diet or supplementation becomes the only realistic path. Unfortunately, dietary sources are extremely limited. A handful of animal products like cod liver oil, UV-exposed mushrooms, egg yolks, and fatty dairy contain some, but rarely enough to meaningfully move the needle on their own, which leaves supplementation as the practical solution for the vast majority of people. Step 2 is digestion and absorption. Whether from food or a supplement, vitamin D has to be broken down in the digestive tract, which requires proper digestive enzymes. And because vitamin D is fat-soluble, it needs to be consumed alongside dietary fat and adequate bile release to be absorbed properly. Eat a very low-fat diet or take your supplement on an empty stomach, and a significant portion of that vitamin D may never actually get absorbed. Interestingly, some research suggests taking vitamin D with your largest meal of the day, when digestive activity and fat intake are highest, can boost absorption by as much as 50%. Step 3 is transport. Getting vitamin D into your bloodstream still isn't the finish line because vitamin D doesn't travel freely. It needs to be carried by a specific transport protein, often referred to as vitamin D binding protein. If levels of this protein are low, vitamin D simply can't get delivered efficiently to the tissues that need it, regardless of how much you're taking. Low levels of this binding protein have actually been associated with increased risk of certain cancers, including breast, prostate, and colorectal cancer. And the encouraging part, even modest, consistent supplementation, in some studies as little as 1,000 international units daily, has been linked to notably lower cancer risk in these contexts, in some cases reducing risk by 60 to 77%. But transport alone still isn't the finish line either. Step 4 is cellular entry. Vitamin D has to actually get inside the cell to do anything useful, and that requires a receptor, often called the vitamin D receptor, sitting on the cell's surface, acting almost like a lock waiting for the right key. These receptors exist on nearly every cell type in the body, but they're especially concentrated in places where vitamin D's role is most critical: kidney cells, immune cells, bone cells, and multiple regions of the nervous system. One particularly striking example is the substantia nigra, a brain region responsible for producing dopamine, the same region implicated in Parkinson's disease. Low vitamin D receptor activity there has been linked to reduced dopamine production and a higher long-term risk of Parkinson's. Another key area is the hypothalamus, which regulates hormones, hunger, thirst, and temperature control. When these receptor-dense regions aren't getting enough vitamin D activity, the downstream effects can show up as neuropsychiatric issues like depression or schizophrenia, neurocognitive issues like Parkinson's or dementia, and a wide range of hormonal and endocrine imbalances, including diabetes, which has one of the strongest documented connections to vitamin D receptor activity of any condition, affecting both type 1 and type 2 diabetes through reduced insulin release and increased insulin resistance. Step 5 is cofactors. Even after clearing every one of those hurdles, intake, absorption, transport, and cellular entry, vitamin D still can't function optimally on its own. Almost no nutrient works in isolation, and vitamin D depends heavily on a supporting cast. Nutrient-dense whole foods, prepared properly, provide the broad foundation of cofactors your body needs more than anything else. Regular exercise activates cellular function throughout the body, helping every tissue use available nutrients more effectively. Beyond that, having sufficient vitamin D intake in the first place is obviously non-negotiable, whether from sunlight or supplementation. Magnesium is arguably the single most important cofactor, participating in hundreds of biochemical reactions that vitamin D depends on. Omega-3 fatty acids, EPA and DHA, support vitamin D's activation and transport. Zinc plays a supporting role across multiple pathways. Boron is another often overlooked essential mineral, and vitamin K2 rounds out the list, working alongside vitamin D in calcium regulation. Though in practice, many people do better starting with vitamin D3 alone for a few months before introducing K2 rather than combining them from day one. Part 4. How much should you actually take? Standard guidelines recommend at least 600 international units daily for most adults, rising to 800 for those over 60. In clinical practice, many people need closer to 5,000 IU daily to move their blood levels into a healthy range, and some individuals still test deficient even after months at that dose. Going up to 10,000 IU is sometimes necessary, but it's also where the risk of overshooting into toxic territory starts to increase. Because there's so much individual variation in absorption, in transport protein levels, in receptor sensitivity, in cofactor availability, there's really no way to know your correct dose without testing. Part 5. Reading your own numbers. Once you get vitamin D added to a blood panel, here's how to interpret the results. Below 20 nanograms per milliliter is deficient, clearly in the danger zone. Between 20 and 30 is considered insufficient, better, but still too low for optimal function. Most practitioners focused on nutrition and long-term function consider the real optimal range to sit between roughly 50 and 80 nanograms per milliliter. If you're using nanomoles per liter instead, multiply your nanogram number by roughly 2.5 to convert. Why aim for the higher end of that range rather than just scraping by at 30? Because individual variability is so significant in how well you absorb, transport, and utilize vitamin D that having a buffer protects you against the many possible weak links in that chain we just walked through. But there's also an upper boundary you don't want to cross. Vitamin D toxicity is real, and it typically shows up above roughly 150 nanograms per milliliter, where it can start driving blood calcium to dangerously high levels. Getting there usually requires very high doses sustained over a long period, so it's not something that happens accidentally, but it's exactly why testing matters instead of guessing. At this point, hopefully it's clear why vitamin D deserves far more attention than take a pill and hope for the best. It touches your immune system, your brain, your hormones, your cancer risk, and your long-term resilience against chronic disease. The only real way to know where you stand is to test. Adjust your dose based on actual numbers, retest every couple of months until you stabilize, and then maintain from there. Once you understand your baseline, you won't need to test as frequently. But skipping that first step means you're just guessing with something that influences nearly every system in your body. If this changed how you think about vitamin D, you'll want to see what's coming next, because understanding how your body actually works is the foundation for everything else we're going to cover.